Okay, so in this video, I'm just going to explain the GADD45 gene. So the function of it is pretty much that it blocks DNA replication as well enhance the nucleotide excision repair. So pretty much it's used when the DNA is damaged, and it'll help send signals to help correct the DNA. So along with this, P53 binds with it because P53 is also used to help with DNA repair by slowing the cell cycle and going over the DNA to see if there's any errors and then repairing those errors. So first I'm going to draw the promoter of the GADD45, and I'll label the start site, the title box, and the P53 binding site. So pretty much, the promoter is, well, I'll start with this. So the promoter would be found between nucleotides -65 to -100. Yeah, I guess you could see it. So that we'll say that the promoter would probably be around here. That should be -65. -100, -65. Now, the title box is located from nucleotides -25 to -15, so I'm just going to try to look down the line because it goes from negative, and then +1 would be positive when it starts transcription. So we'll say that this is the title box, and we said and then the start of transcription would be AUG, the nucleotide sequence AUG, which just codes for like the start. So the gene knows where to start transcribing. Happens after the title box, and if it does start transcribing, this would indicate the start of transcription. Now, P53, if you can see. Here, P53 would bind to the promoter, so we'll just put P53 under here. So if P53 is needed, then it will bind to the promoter. So now I'm going to draw the promoter of the GADD45 that's not experienced UV light damage. So if it's not experienced to UV light damage, then the cell has no need to repair anything because it's not damaged. So pretty much the P53 would not bind to the promoter because there's no need for it right now since there's no damage. And then the GADD45 would not continue necessarily. Yeah, it would not continue since it's really not needed. The gene isn't needed if there's no UV light damage. So transcription really wouldn't happen because there's no binding to the promoter. P53 wouldn't bind to the promoter. So pretty much what this gene would look like. If there's no binding, then it would just not. Okay. It would just not happen. Transcription would not start since P53 did not bind to the promoter, then therefore doesn't allow for the start of transcription through the title box and the AUG nucleotide sequence. So then on a gene that does have DNA damage. Okay, this is not gonna work for me now. On a gene that does have nucleotide damage, experience UV light damage, the P53 would bind to the promoter. So pretty much, I'm just gonna draw it like this, but you could just see this as the promoter, and then P53 would bind to the promoter. Now, the binding of this allows for the continuation through the title box, which allows for the signal to start transcription through the AUG nucleotide sequence. And this would just be shown like this, as in it would start transcription. So then I have to draw the cell, to draw the promoter of the GADD45 in the cell that lacks P53 and has experienced UV light and damage. So if the cell lacks P53, there would be no P53 to start the promoter, but it does have DNA damage because there's no P53 to bind to the promoter to allow for this gene to start transcription. Then the cell would have damage but can't use the GADD45 to help. Like the GADD45 would not efficiently be able to work since the P53 isn't there to bind to it to start the transcription of the gene. So we would just, once again, if it can't be transcribed, we'll put an X through it. This gene really doesn't help very much for the cell, and if the cell still is already damaged from UV light, and the GADD45 is not able to help the cell and help with the DNA repair, the gene will most likely go through apoptosis or have mutations. But if the P53 isn't able to bind to this gene and the gene isn't able to work and effectively help the DNA and repair the DNA, there will be more mutations, but then the more mutations there are, the more likely the cell is gonna go through apoptosis. So most likely after a period of time, over more mutations, the cell will eventually go through apoptosis.